So the band,
yeah, von Willebrand factors.
yeah, so those factors, when they, like, they basically get full, I mean, are there a certain amount of those that kind of connect to the extracellular?
Yeah, I mean, it's kind of tough because you're looking at like a 2D model, but I mean, I guess you could imagine that, like, if you were looking at it from an overview, you'd have you'd have lots of them basically. You have them in every location, so you pretty much, they keep being synthesized and output onto the basement membrane until you've filled up that entire area that that could possibly be covered by that. So that way.
And then they activate a certain amount of the platelets, inactive platelets, connect to those.
Yeah, like
and then how you get like the more clotting is more from like all of the other stuff, right? So like the ADP and the calcium.
Yeah, so your platelets, your von Willebrand factors activate your initial platelets, and this is actually termed platelet adhesion. So like that's like one step, and then the next step is platelet aggregation, and that's like platelets activating other platelets and just continuing to stack on. So what you end up with, where's my eraser? What you end up with is, after like all the recruitment, is that there's little like fibrinogen, which fibrinogen serves two purposes. One of the purposes is forming fibrin, which fibrin will be important a little bit afterwards, but another purpose of fibrinogen is actually it binds platelets to each other. So what you end up happening is, after this initial platelet adhesion, you end up with this platelet aggregation, where you have just more and more platelets coming in, and they just kind of, they're just everywhere, and they just kind of block off the entire area. And so just, basically so that you prevent any more, flowing out of blood, nutrients, and everything else that you're trying to inhibit from being released from the vasculature. So yeah, the next thing I guess we could talk about is a couple of the drugs that have effects on the clotting. And so when you have your platelets that are activated, one of the things they release is the ADP and the TXA2, and certain drugs that block the ADP pathway include Plavix, and basically what these drugs do is, by blocking the ADP pathway, they block the continued activation of more platelets that leads to this platelet aggregation. The other way that drugs can kind of block this platelet aggregation is by blocking the TXA, the thromboxane A2 pathway. And the way a lot of these drugs do it is they actually inhibit one of the precursors of TXA2. Drugs that will do this include like your NSAIDs, aspirin, ibuprofen, Tylenol. A big difference is that aspirin, acetylsalicylic acid, it binds permanently to cyclooxygenase 1, or COX-1 as it's referred to, and by binding permanently to it, it stops this TXA production pathway from ever occurring as long as the platelet lives. And platelets live 8 to 10 days, so that's why aspirin can have a much longer effect. Whereas all your other NSAIDs, they block the cyclooxygenase pathway just for the amount of time that they're in your system. So we're talking, instead of days, we're talking just about the hours, 4 hours, or however long they last in your system. So I'm trying to think if there's any other ways. Yeah, I guess the next thing would just be to look at how the the coagulation cascade occurs. So,
Professor,
yeah.
we should think of adhesion as like all prior to coagulation. Is that what you're telling us all?
I would say adhesion is prior to aggregation. Coagulation is, it's more of like a broad term. Adhesion is the preliminary part of coagulation. I believe coagulation, and also the distinguishing difference would be that coagulation can occur anywhere, whereas for platelet adhesion to occur, you're literally talking about the platelets actually being stuck to the basement membrane. So coagulation could occur, somewhere in the middle of your pathway, in the middle of your vessel, and just send a clot down. It doesn't actually need. It's easier if it occurs, attaching itself to a von Willebrand factor, because that is, a natural way that platelets are activated. But platelets don't have to be activated by that. They can, in fact, initiate the coagulation cascade, without any sort of attachment. Obviously, would be an improper action, but it does occur. So, I guess the next thing to look at is how the coagulation cascade occurs. And coagulation cascade runs through two different pathways. Both of them are pretty much working all the time. They're kind of like a backup for each other. And so the way that the coagulation cascades occur is there is a intrinsic pathway, and then there's an extrinsic pathway. So the intrinsic pathway is a contact activation pathway, and basically what is meant by intrinsic is the fact that it doesn't really require anything like any external source for the pathway to be started. Everything that you need for the intrinsic pathway you already have within your vessel, whereas your extrinsic pathway is also called your tissue factor pathway, and the extrinsic pathway requires tissue factor release. And so the tissue factor, which is released from the subendothelium, if there's a puncture to the vessel that's great enough to actually bother the extracellular matrix and the subendothelial cells, then that's a way that you can get this tissue factor to be secreted and your extrinsic pathway to start. So this is your extrinsic pathway, and then we'll talk about your intrinsic pathway. So your extrinsic pathway, I'm having difficulty spelling right now. Your extrinsic pathway is by far your faster pathway. It requires an external stimulus for it, but once it gets going, it pretty much skips over a lot of the intermediate steps and gets goes right to it. So basically, if you had an issue within the intrinsic pathway, as long as you still have some of the coagulation factors that are required for the extrinsic pathway, it wouldn't be such a big deal if you were a bit short on some of the other coagulation factors, which does occur because in say disseminated intravascular coagulation, like DIC, one of the big things that happens is a lot of your coagulation factors get used up, and when they're used up, you end up you end up with a lot of excess bleeding. So it's this paradoxical effect, because you have hypercoagulation at first, followed by no coagulation and excess bleeding, just because of a lot of these factors being used up. But basically, having both an intrinsic path and an extrinsic pathway is a way to protect yourself, so that and also kind of just supplement your clotting so it just occurs faster. So the intrinsic pathway starts off with your activated platelets. What happens is